All right, we are going to review electron configurations. So number one, how many electrons will fit in an S subshell? Well, if you remember, an S subshell is just one orbital. So every orbital can only fit 2 electrons. So 1, 2. Sometimes you'll see this notation as an up arrow and a down arrow. So each slash in my little circle stands for 1 electron. All right, how about the next one? How many electrons can fit in a P? Oh, sorry, the answer to that one was 2. So P subshell, I'll go over here, is really 3 orbitals. So 1, 2, 3, 4, 5, 6 total electrons could fit in there. A D subshell is 5 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons can fit in a D. And an F subshell is 7 circles, 7 orbitals, so you can fit in 14. How about the entire first shell? Well, the first shell just has a 1s. So we call it a 1 because it's in the first shell, and then it just has an s. So only 2 electrons can fit. But the second shell has a 2s and a 2p. So 2 can fit in an S plus 6 can fit in a P. That makes 8. How about the third shell? That's 3s, 3p, 3d. That's 2 plus 6 plus 10. That makes 18. The fourth shell has a 4s, a 4p, a 4d, and a 4f. That is 2 plus 6 plus 10 and a D plus 14, that makes 32. Another clever way you can figure that out if you didn't like that is you can just count how many electrons fit in the first shell. Well, 1, 2. How about the second shell? You just count 1, 2, 3, 4, 5, 6, 7, 8. How about the third shell? 1, 2, 3, 4, 5, 6, 7, 8, plus this is 3D right here, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How about the fourth shell? Anything with a 4 in front of it. 1, 2, over here, 3, 4, 5, 6, 7, 8. We've got the 4D, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then the 4F. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, and we're not going any higher than that, so don't worry. How many core electrons and valence electrons in the following elements? Well, you have to look at the periodic table and see which group it's in. Okay, so for cesium is number 55. It's in group 1A. That means that it's got 1 valence electron. Anything in group 1A has 1 valence electron. Since it's number 55, that means it's got 55 total. So how many are left in the core? Core electrons are anything not in the outer shell, so everything else. So you would do 55 minus 1, that's 54 core electrons. How about tin? Tin, if you look it up, is number 50. It's in group 4A. So that means it's got 4 valence electrons. 4 valence. And since it's got 50 total, you do 50 minus 4. It's got 46 core electrons. How about writing out electron configurations? Let's start with magnesium. So remember, you always start at hydrogen, and it's like you're reading a book. You travel across, and every time you hit a double line or a highlighted part, like you did on yours, you write down what's there. So 1s2, we keep going. We hit this wall, 2s2, keep going, 2p6, and finally we get to magnesium, so we can stop there and write whatever is on its square. 3s2 in this case. Okay, let me write this in. So 1s2, 2s2, 2p6, 3s2. How about barium? Well, barium's the same thing. It's just going to be really long. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then it skips down 1 in the transition metals. 3d10, 4p6, 5s2, 4d10, 5p6. Finally, you get to Ba, which is 6s2. I don't even know if I'm going to be able to fit this on here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, oh no, continued, 4d10, 5p6, 6s2. Number 4, which element has 5 electrons in the 3D? Well, let's find the 3D. Which one has 5 in it? 1, 2, 3, 4, 5. Number 25, manganese. Which element configuration ends with 3p6? Or I can just add up all the little numbers and find the total number of electrons. It adds to 18, and that is argon. How about the shorthand configuration? How do you do that again? Let's look at aluminum. You go back to the last noble gas before aluminum. That would be neon. So we put neon in brackets and we continue from there. 3s2 and 3p1. How about gallium? Gallium's number 31. The last noble gas before gallium is argon. So argon in brackets, 4s2, 3d10, 4p1. Get these written down for you. Neon, 3s2, 3p1. Gallium is argon, 4s2, 3d10, 4p1. Identify the valence electrons in the following elements. Okay, well, let's figure out strontium first. So if you wrote out the whole configuration for strontium, it would end in 5s2. So those are the outermost shell because 5 is the biggest number out front. It's got 2 valence electrons. But lead is a little trickier. Let's look at lead. Here's lead, number 82, 6p2. Well, if you're writing out its configuration and you go backwards, you'll see that you'll have written 6s2, 5d10, 6p2. So the ones with the 6 out front mean that that's the outer shell. So 6s2, 6p2, and it's got 4 valence electrons, 2 and 2. Number 7, how many electron shells does argon have? Argon's number 18. It's in the 3rd row down. That means it's got 3 shells. It's in group 8A, so it has 8 valence electron. And its outermost shell is just the 3rd one. That one's kind of a stupid question. Sorry. Number 8, write the electron configuration for argon. This is easier compared to what we've been doing. So 1s2, 2s2, 2p6, 3s2, 3p6, and which are the outermost electrons? Well, look for the biggest number out front. These are the outermost electrons. So those are the valence electrons. And what's 6 plus 2? Well, it's 8, just like we said it was going to be. Finally, the shorthand for argon, you can just cheat. Just put argon in brackets. All right, good luck.